Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our Kotlin Interview Questions course. My name is Alexandra Kropova. I am a 10-time course instructor, and I will be guiding you through your Kotlin coding interview preparation. In this lecture, we're going to overview the 10 different sections that we will cover in this course. We are going to cover the most popular questions asked by the likes of FAANG companies, that is Facebook, Amazon, Netflix, and Google. And we are going to look at the 10 most popular categories at the coding interview. Let's jump right in. In section 1, we're going to look at the string and array data structures. So we are going to look at interview questions covering this topic, and strings and arrays are some of the biggest topics asked about. That's why it's number 1 up there. We're going to solve after Fizzbuzz, reversing words in a string, rotating array, and finding the kth largest element in an array. Questions like that. Then in section 2, we are going to look at the matrix data structure, and we will learn how to implement algorithms pertaining to matrix interview questions. We'll solve questions like setting matrix zeros and printing a spiral matrix. Then in section 3, we'll look at another common data structure that is asked about at the coding interview, and that is the linked list. We will learn how to build a linked list and also a queue. So we're going to hit 2 data structures in one in section 3. Then in section 4, we will learn about the binary tree data structure. We'll learn how to implement a binary tree and visualize one. In section 5, we are going to look at the graph data structure. We'll learn how to build a graph. Then in section 6, we are going to cover sorting as well as time complexity. We're going to look at the sorting algorithms that you need to know in order of most inefficient to most efficient. So we'll be looking at time complexity and comparing and contrasting the different use cases of different sorting algorithms. Another huge topic. Then in section 7, we are going to be looking at the dynamic programming algorithmic paradigm. This is an algorithmic paradigm that you should know about, so we're going to cover questions like finding the coin change, finding the maximum sum subarray, and finding the edit distance between 2 strings. If you don't know any of these terms, not to worry, we're going to cover all of the computer science and math terms that you need to know in this course. Then in section 8, we are going to look at bit manipulation. If you can master bit manipulation, you'll be able to build impressive solutions that will impress your interviewer. So we're going to look at what is bit manipulation, what are the bitwise operators you can use, and we're going to see exactly how efficient bit manipulation can be. Then in section 9, we are going to look at combinations and permutations. We'll define these terms which come from math, and we'll solve questions like finding permutations, combinations, and the popular letter combinations of a phone board. After those questions, we're going to look at math interview questions. Similar to bit manipulation, mathematical solutions to interview questions can provide highly concise and fast algorithms that can work extremely efficiently on huge data sets of up to millions of elements. So we're going to look at different patterns of questions where math comes up over and over again, and where you can recognize your ability to use math for certain questions instead of a slower solution like iterating or using recursion, sorting, or even dynamic programming. Math can beat out even those paradigms. So we're going to cover those patterns and questions in section 10, questions like reversing an integer using math, finding the palindrome number, and the popular Excel sheet column number question. we're going to have questions of all difficulty levels so you can see exactly where you are in terms of your readiness for the coding interview. And in all of the categories, we're going to look at the patterns of questions, because with the coding interview, it's not about knowing exactly how to solve every question, but rather it's about learning the patterns of questions that come up over and over again. That way, regardless of how the hiring manager or the employer twists a question, you'll be able to recognize the pattern and boil the question down to what it is asking of you in the most simplest terms. And based on your pattern recognition, you'll be able to solve any question that they throw at you. Let's go ahead and look at the free IDE integrated development environment that we'll be using in this course. No installation or downloading is required. We are going to use the Kotlin Playground. This here is the Kotlin Playground, and I'm going to give you a quick tour. To find this Kotlin Playground, just type in play.kotlinlang.org and you'll be taken to the official Kotlin Playground. And as you can see here, we have our file and we can write all of our code here, and any code that we call in our main function. As soon as we hit this big blue run button, the console will print out whatever we have specified in the main method. And we can also close the console, and we can change the settings and the run configuration. We can also share our code by linking, embedding, and more. We can get help. We can also look at documentation with these buttons above. The Kotlin Playground is quite an easy online sandbox to play with, because you don't have to install, you don't have to sign up. You just visit play.kotlinlang.org and you can instantly test out your interview solutions. I don't know about you, but I am very excited to start this journey with you all in our Kotlin interview questions preparation. This is my 10th course here at our online school, and Kotlin is an extremely relevant and in-demand language. So if you're choosing a language to prepare with for the coding interview, Kotlin is hireable. That is why we're choosing it for our course today. Head on over to the next lecture and we'll get started. Hello everyone, and welcome back to our Kotlin interview questions course. In this lecture, we're going to be solving the Fizzbuzz interview question. This question is almost synonymous with the term interview question, so we're going to start with it. The question goes: print the numbers from 1 to 100, and for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz. Immediately, we want to think about the edge case of this question, as we would with every question. An edge case means a special case that is not obviously stated in the question. For example, in this question, what would we print if we had a number that is a multiple of 3 and a multiple of 5? Well, in that case, we would want to print fizz and buzz. As you can see in the output, we have an example of the kind of output we're trying to recreate, where we're beginning with 1, then 2, then we're printing fizz because 3 is a multiple of 3. Then we're printing 4 because 4 is not a multiple of 3 or 5. Then we print buzz because 5 is a multiple of 5. And at 15, which is a multiple of 3 and 5, we are printing Fizzbuzz. It's common to forget to print a number where a number is not divisible by 3 or 5. Now, in order to find if a number is divisible by both 3 and 5, you can check if a number is divisible by 15. Because, as you'll see in this example, if a number is divisible by 3 and 5, it must be divisible by 15 as well, because 3 times 5 is 15. Those are some rules that come from math. Let's go ahead and solve this problem. What we can do is use the modulo operator to check if a number is a multiple of another number. So first we're going to open up a main function. This is going to open up our application so we can test all the code that we write. And in here we can open up a new print line call to print a line to the console. And we'll print beginning at 1 and ending at 100. And what we'll do is we'll use a map structure in order to map all of the values we want to print. The map will help us print either a number or fizz or buzz or both, depending on the number we're currently at. So I'm going to go ahead and open up the printline function, and it will immediately close itself for me as well. And I can just fix the indentation here so it's easy to follow along with. And now we have the printline function set up. And we're printing from 1 to 100, but we're going to map the values that we want to print. So I'll open up a new local variable index, and I'll make a map of from 0 to the index. I'm going to print out several values depending on if the index is divisible by 3, 5, or both, or neither. If the index is divisible by 3, I'm going to print fizz. So I'll say index mod 3 to fizz. I'm mapping the index mod 3 to print fizz. And similarly, I'll map index mod 5 to buzz. And finally, I'll map the index mod 15 to fizz buzz. And this is going to create a map of different values depending on if the number we're currently at is or is not divisible by 3 or 5. And I can also add this 0th index at the end of my map in order to see all the values. Alright, so now that we have this set up, we can just go ahead and hit the big blue button called Run, and the playground is going to print out my output. As you can see, I'm beginning at 1 and then printing 2, and then I'm printing fizz because 3 is a multiple of 3. And at 5, I print buzz instead of the number. But for any number like 7 or 8, which is not divisible by 3 or 5, I'm printing the number itself. And at 15, you'll notice I print fizz and buzz. And we have to check that this output goes all the way up to 100, which it does. At 100, you can hardly see it, but it's buzz. We have fizz and then buzz. And that's because 100 is divisible by 5, but not 3. Therefore, we print buzz. Alright, so congratulations everyone on solving your first interview question. We're going to be continuing on in the next lecture. We're going to be looking at our first category of the top 10 categories of questions you'll be asked about at the coding interview. Head on over to the next lecture. Hello everyone, and welcome back to our Kotlin interview questions series. In this lecture, we're going to solve the reverse words in a string interview question. The question goes, given an input string, reverse the string word by word. For example, if we had an input string reverse words in a string, the output of that would be string A in words reverse. In order to solve this interview question, we're going to have to split the input string at each of the space characters in the string, and then we're going to have to create a string array from the input string, reverse the string array, and then join the different elements in the array back into a new string, which will now be a reversed string. Let's go ahead and do just that by opening up a new function. We'll call this reverse string, and we'll put in a string to reverse as our input. What we will return here is going to be the string to reverse. So we can open up curly brackets and return a value, or we can just use the equal sign as a shorthand. And we are going to take the string to reverse and perform some actions on it. You can do this all on one line. I'm going to separate the different functions that we're going to call onto different lines for better readability. First, we're going to split the string at each character space, just like that. And we'll be having here a character array, a string array, rather, of the input string split into different words. After we have that array, we're going to call the reversed function to reverse the array. And then we're going to call join to string at every space. That means that we're going to take each space character and we're going to use a space character to combine all of the elements in the character array. We'll join all the elements in that array together and we'll separate them all with a space. And just like that, we have all the functionality we need to reverse a string. We can go ahead and test this now by opening up a main function. A main function opens every application. And first we'll make a value called string to reverse. This can be reverse words in a string. And then we want to call the print line function and call our reverse string function on the string to reverse. And just like that, we will print the reversed string. Let's hit run to see that in action. And we'll see string A in words reverse. That's exactly what we expected. A common mistake is to print the reversed string letter by letter, but it's important to read each question carefully because the question said to reverse the unique words rather than the unique characters. Reverse the string word by word. We successfully solved this interview question. Congratulations everyone. In the next lecture, we're going to be looking at more questions pertaining to strings and arrays. This is one of the largest categories asked about, so that's why we're covering it first. Head on over to the next lecture. Hello everyone, and welcome back to our Kotlin interview questions series. In this lecture, we're going to solve the rotate array interview question. This question goes, given an array, rotate the array to the left by k steps, where k is non-negative. For example, if we had an input of an array with the values 1, 2, 3, 4, 5, 6, 7, and k was equal to 2, that would mean we need to rotate the array to the left by 2 steps. Left array rotation means we must take the first 2 values in the array and move them to the end of the array. And we'll be left with an output of 3, 4, 5, 6, 7, 1, 2. In order to solve this question, we can loop through all of the values in the array and store a new array that ends at the kth index minus 1. Then we can go ahead and add that array to the end of the initial array after we have deleted the first k elements minus 1. Let's go ahead and do just that. We'll open up a new function. It's going to act on an integer array and it's going to left shift the integer array by a value of k. And we'll have to return an int array that will be the input array shifted. So first we'll make a value called our shifted array. This will be equal to this dot copy of. So we're storing a copy of the array that we're left shifting. Now you can also just manipulate the given array, but we're going to work with a copy for this particular solution. Then we'll go ahead and make another variable called rotate by, and this is equal to k. This will help us have more readable code because instead of a random letter k, we'll have a rotate by as our variable. Now first let's check the edge case if rotate by is greater than the size that we have of the array. So let's check that. We'll check if rotate by is greater than the size of this array. If so, it means that we have a value of k that requires us to perform more than one 360-degree rotation. Therefore, we have to take rotate by and mod it by the size. So we'll take rotate by and assign equal to rotate by mod the size. For example, if we had a k of 10, then we would want to rotate the array 360 degrees plus 3 units. And we don't care about the 10, we only care about the last values, the 3 units, because our array has 7 elements. Therefore, if we had rotate by of 10, we would take 10 mod 7, which would give us the remainder of 3. After we have accounted for a larger k value, than the size of the array, we can actually go ahead and perform the functionality and build the algorithm that will shift the array. So we'll use a for each loop for that, for each index, and we're going to use an index and a value for this in order to loop through all of the values in the array. We're going to make a value called our shifted index, and this will be equal to the index plus the size minus rotate by mod the size. This is going to give us the shifted index that we need because we're storing up all of the values up to the kth value -1. And that -1 is just due to zero-based indexing. So after this, we'll take our shifted array and we'll add at the shifted index the value. So we're creating a new array, and this time we have shifted the values by the value of k. After we have gone through each of the indices, then after that, what we're going to do is return what the array requires, which is an integer array. This function requires an integer array, and we're returning the shifted array, just as the name suggests, shifted array. And just like that, we have the entire functionality we need in order to left shift an array. Let's now test this by opening up a main function that will perform all our main functionality. We're going to make a value called our array to shift or array to rotate, and this will be equal to an int array of values like 1, 2, 3, 4, 5, 6, 7, just like we saw at the beginning of the lecture. And we have to call our array to rotate dot left shift function by a value of 2 on the array to rotate. And you'll remember that we returned a copy of the array but rotated, so we'll have to make a new value called rotated array, and this will be equal to the array to rotate dot left shift. Now we have to print out all of the values of the rotated array. So we'll make a for loop. We'll say for element in rotated array, we will print the elements. And just like that, we have the testing functionality we need. So let's go ahead and hit run, and we'll see printed in the console we'll have 3, 4, 5, 6, 7, 1, 2. This means that we successfully left shifted the array because the first value being printed is now 3, and 1 and 2 have been left shifted to the end of the array. I challenge you to also do a variation on this question that you may also be asked, and that is the right shifting. Right shifting is similar to left shifting. However, with left shifting, you take the first k elements and you rotate them to the end, but with right rotation, you take the last k elements and you rotate them to the beginning. So the output for a right array rotation would be 6, 7, 1, 2, 3, 4, 5. I challenge you to take each question one step further in order to challenge yourself appropriately for the interview test, and to try repeating the pattern by right shifting. Other than that, you have completed this interview question. Congratulations everyone on solving another interview question, and in the next lecture we're going to look at another array question in this highly asked category. We're going to look at a very popular question, so make sure to head on over to the next lecture. Hello everyone, and welcome back to our Kotlin interview questions course. In this lecture, we're going to solve the kth largest element in an array interview question. This question asks you to find the kth largest element in an unsorted array. And note that this will be the kth largest element in the sorted order, not the kth distinct element. For example, if we had an array of 1, 2, 3, the first largest is 3, the second largest is 2. If we had an array of 1, 1, 2, the first largest is 2, and the second largest is 1, and the third largest is also 1, because each element is treated as a unique element. So let's go ahead and jump into this solution. In order to find the kth largest element in an array, what we can do is first sort the array and then return the array at the current size minus k, because the only problem we have is that the array is unsorted. But if the array were sorted, well, then we could just get the index k, and that would be the kth largest if the array was sorted in ascending or descending order specifically. So let's do just that. Now, first, in order to use arrays, we'll have to import java.util.star. This way we can actually use an array data type. And once we have the import set up, all we have to do is make a function called the find kth largest, and we'll put in an input array that will be an int array for this example, and we also need to put in a k value, and that will be an int, such as the second largest value in the array. And this function is going to return the int as the kth largest value. Then we can open up the function body, and here we're going to take the arrays from java.util.star, and we'll use the sort function from arrays to sort that input array that we got. And finally, we will then return the input array at the input array dot size, which is the last value index plus 1 minus k. And just like that, we have the solution. Kotlin provides quite efficient solutions in terms of the code complexity. And so now let's actually test this out. We'll open up a main function, and then we'll call print line to print to the console, and we'll call our find kth largest function, and we will make an int array of some values of a random array here of values. You'll notice the array is unsorted. I did that on purpose, so that way we will then have to force the sorting with this line arrays dot sort. So after this, we also have to put in the k value for this function to be valid. So we have our array, and let's put a k of something like 2. So we're finding the second largest value in this integer array. Now, can you predict what it will be? Well, the second largest is going to be 4 in this case. So I'm going to test this out by hitting run, and I'll just zoom out. And as you can see, 4 is being printed in the console. That's exactly what we expected. And we can test this on other values, such as having duplicate values and then hitting run again. And you'll see, don't know what happened here, but you'll see we have 5 being printed in the console now, because this solution will find the second largest distinct element, which in this case is going to be 5 because we have 2 5s there. Congratulations, everyone. You just solved the find the kth largest element in an array interview question. Head on over to the next lecture where we're going to be beginning. Hello everyone, and welcome back to our Kotlin interview questions course. In this lecture, we're going to solve the set matrix zeros interview question. Sometimes a modification is called the set matrix ones interview question. This question asks you to take a matrix, a two-dimensional array, and at every index that has a value of 0, change the entire row and column that is associated with that index to also contain a 0. And typically you will also get a constraint that you must solve this question in place, which means that you cannot use any more memory. You must work with the given matrix. And in order to perform this, let's go ahead and jump into our screencast. To solve this question, what we can do is make a function that is going to get a matrix, and it's going to loop through its rows and columns and check each element in each row and column, and if it finds a 0, it's going to set the entire row or column and both if it sees a 0 anywhere in the matrix. So let's go ahead and do just that here. I'm going to come down below the sample code of the actual question and some input and output examples, I'm going to make a new class and I'll call this set matrix zeros, and I'll open up the class like that. Now in this class, what I want is to make a new function that's going to set my zeros. So I'll say set zeros for the function name, and I'll put in the matrix as an integer array, and it's going to return a unit as my function return value. Then I'm going to make a value called the rows, and that's going to be the number of rows. And to get the number of rows from a matrix, all you have to do is call the matrix by its name dot size. So we're accessing the size property just like that. And let's see what it's telling me here. I'm just going to hover over this. This variable must have a type annotation or be initialized. Variable rows is never used. That's fine. That just means we're about to use the variable shortly. So what I'm going to do is also get the number of columns. So I'm going to make a value called calls, and this will be equal to the matrix at the first row dot size. So to get the number of columns, you just get the number of elements in each row. And first I'm going to go ahead and set the first row and column, because that way we won't have to go through all of them immediately. We'll start by checking the first row and column for this solution. So I'm going to make a variable called first row, and initially it will be false in terms of does it contain a zero as well. First call also be false. Then I'm going to loop through all of the values starting in the rows. I'm going to make a for loop for row in 0 until the rows, and I'm going to use a nested for loop to go through all of the elements. So I'll say for call in 0 until calls. So we're going through all of the elements there. And inside of here, what I want to do is check if the current element contains a 0. So I'll say if the matrix at the current row and the current column is equal to a 0. If so, then that means that we want to perform another check. If the row is equal to 0, then that means we have currently reached the first row. So we will, in that case, what we'll do here is we'll set the first row to equal true, because that means that we have just reached the first row. Otherwise, we'll perform a check. If the column is equal to 0, that means we are currently at the first column. So we'll set first call to equal true. And after this, what we'll do is we'll take the matrix at the current row and at that 0th column. We'll assign it to equal 0. So that means that we're setting all of the values in the first column to 0. And as well, we'll do similar for the first row. So we'll take the matrix at the first column. Did I say first row? I meant first column. And then at the current column, and we will assign it to equal 0 as well. So we're starting with that top row and the top or leftmost column. After we have gone through the 0th index, we can then go through all the other indices. So I'm going to make sure we're outside of this nested for loop, both of the for loops, and still inside of the function set zeros, because we're still setting zeros. And what I'm going to do is open another nested for loop for row in 1 until size, or we called this rows, didn't we? Yes. For row in 1 until rows. And what I'm going to do in this case is I'm going to check if the matrix at the current row and at the 0th column is equal to 0. If that is true, then I'm going to go through all of the columns. So for call in 1 until the calls, then I'm going to, in this case, what I will do if all those conditions are true is I'll take the matrix at the current row and at the current column, and I'll assign them equal to 0, just as the question requires. And I'll do similarly for all of the columns of this pattern that we're currently doing. So I'll make another for loop for the call in 1 until calls. And in this case, I'm going to check if the matrix at the 0th row and at the current call is equal to 0. If so, then I'm going to go through for row in 1 until rows. We're going through all the rows now. So as you can see, we're quite systematic in our approach, and we'll take the matrix at the current row and at the current column, and we'll assign it equal to 0. And let's see, outside of this nested for loop, we can then check if we're at the first row. Then we want to go through for the column in 0 until the end of the columns. We want to go through all the columns in the first row and take the matrix at that 0th first row and at the current column and assign it equal to 0. And similarly, we want to perform the check for if the first column has a 0. So we'll check if first call is true. That means it has a 0, which we set earlier in the code. And we'll say for the row in 0 until the row's end. And what we'll do is we'll take the matrix at the current row and at the 0th column, and we'll assign that equal to 0. And just like that, we have our solution. Now, as you can see, we have to go through quite a few iterations through the matrix. So this is quite time consuming, but that is to be expected with matrices. Typically, you'll have a larger time complexity because you have to go ahead and loop through a table of values, which is quite a lot of values. So let's go ahead and test out this code. Just go outside of the class. Make sure you're outside of that class that we built. And let's open up a function called main that will open up our application. And we will put in an argument of an array. We'll make it of strings. And then we'll make an array. First, we'll make a value called set matrix zeros. And this will be a new object called set matrix zeros of our class. Now, we actually have to capitalize this because we must have the capitalization be exact. And that set matrix zeros, it corresponds to our class here. And in fact, we'll just call this matrix zeros because typically for class names, you don't want to include verbs. So I'm just going to come down here. Matrix zeros. Okay, excellent. And I'm going to call this matrix zeros as well. And then I'm going to go ahead and next I will make a value called our input array. And I'm going to make this an array of several values. So first I'm going to populate it with an array. We're going to put in several integer arrays into one big array. So I'll make an int array of the values 1, 1, 1. Separate each row by a column. So this represents each row in the matrix. I'll also make an int array of 1, 0, 1. And we can put the 0 anywhere for the testing. It's not a big issue. Any test you want to perform, you can perform it in a main function. So we also have to add in that last row, and we'll put in 1, 1, 1 as the values there. Now we have our array and our class. What we have to do is call the class matrix zeros, the object we created an instance of the class with. Then we call its function, which is set zeros, and we put in the required argument there, which is going to be our input array. And then we can just input array. And then we can just go ahead and call print line on the input array dot map. So we're making a map so that we can see the result printed to the console. We'll make an iterator to iterate through it.toList. So this is going to print out all of the values in our array here after we have manipulated it by setting its zeros, and it's going to print out the result as a map. Very handy and useful for us to test with in this course. So I'm going to hit run, and as you can see, we have 101, 000, 101 being represented. So we began with an array that had 0 as only the center, but we ended with zeros being in the middle row, as well as being zeros in the middle column, which is just as we expected because we had to set that middle row and the middle column. I want to leave you as a challenge to add a line break between each of these rows because that will allow us to see the result a bit nicer. So I'll leave that as a bonus because the interview test won't typically force you to do that. In fact, the interview test often won't require you to test yourself at all. It will have unit tests testing your solutions against a huge variety of test cases, but for our purposes, it is helpful to test the solution ourselves. It will help you understand the solution when you test it yourself. Congratulations, everyone, on solving the set matrix zeros interview question. In the next lecture, we're going to jump into another interview question pertaining to matrices. So head on over to the next lecture. Hello, everyone, and welcome back to our Kotlin interview questions series. In this lecture, we're going to solve the spiral matrix interview question. This question asks you to print all of the elements in a matrix in spiral order. Spiral order means we're going in a snake-like format along the top row, then down the last column, across the bottom column in reverse, and up the first column, and so forth in a spiral fashion. You'll see exactly how it looks when we jump into the code, so let's do just that now. In order to solve this question, what we can do is follow the pattern of a spiral. So first we will get this first row in the matrix, and then we will go ahead and print all of the values out. Then we will go down the last column in the matrix and just take that first value of each of the values in the column going downward just like this. And then once we reach 16, we'll then go backwards along the last row, and we're going to just follow the pattern through code. Then we'll go finally up the first column here. And what we're going to do is, after we have done one loop through one part of the pattern, such as going through the first row, we're going to then remove that first row from the matrix as though it never existed. And why do we want to do this? Well, because this way we can go deeper and deeper into the matrix. Because let's say we delete this, well then after we have traversed through the first row, then we'll go down the last column and across the last row and then up the first row, and we won't print any duplicate values because instead we'll continue along the same pattern of then printing all of the values in the first row, which will now be a new first row. And similarly, we'll do the exact same for the last column. We'll chop it off as soon as we've printed all of its values, and so forth. We'll do that at each step. So let's go ahead and translate that overview into actual code. So I'm going to come down here, just add a bit of space, and I'm going to make a new class. I'll call this spiral matrix. And I'm going to open up a new function called print spiral matrix. And it's going to take in a matrix, which will be an array. We'll work with integer arrays here. And we are going to, let's see what I did there. And we're going to go ahead and return a list of integers as our result. This list is going to be the matrix in spiral order, just all printed out in a row. So first I have to check the edge cases. Whenever you're working with a problem, you want to think about the edge cases. Now, the edge case will be, what if the matrix is empty? This is a case we don't want to print through because an empty matrix, there's nothing to go through in spiral order. So I'm going to check that edge case. If the matrix dot is empty is true, or let's see, or if the matrix at the 0th row, which is the first row, dot is empty is true. If either of these conditions pass, well, that would be an edge case we want to account for. So what we want to do is return a list of nothing. We'll just return an empty list. Otherwise, if there are no strange cases, then we can actually go ahead and build out the algorithm to print the spiral matrix. So what we'll do is we're going to make a value for the actual table itself. So I'll call this the a table or a matrix size perhaps, and it will be the matrix size times the column size. So it'll be the rows times the columns. So I'll call this number of elements. This will be equal to matrix.size, which is the number of rows, times matrix at the 0th row dot size. And that will be the number of rows times the number of columns. And if you know anything about multiplication tables, then you'll know that that means what we have here is the total number of elements, because we have the rows times the columns. And next up, what I'm going to do is store my result immediately. So I'll make this a value. I'll call this the matrix in spiral order, and this will be an array list of integers, and its size is going to be the number of elements in the matrix. I'm just going to zoom out a little so you can see. There you go. Now you can see it, the entire line. And next up, now that we have declared those values, what we're going to do is go ahead and loop through the values, but we need to actually make another value that will store a Boolean array of each element as we add it. So to do that, I'm going to open up a new value, and I'll call this the printed elements, and this will be equal to the array of the matrix dot size, and we'll populate this with a Boolean array, so true or false values is what we're putting in here. And I'm going to put in the matrix at 0 dot size. That will give me the number of columns, of course. Okay, so now we have populated all the printed elements, and we'll change their values from the default of false as we go along and print all the elements in the matrix. I'm going to first check one other edge case, and quite a few actually. We have some more edge cases to account for. Think about what would we want to print if the number of rows was just 1. Well, if we have 1 row, it's not a matrix because it's just a row, an array. So in that case, there's no spiral order, it's just the row itself. So let's check that. If matrix.size is equal to 1, well, that means that we want to take the matrix at the 0th row and map to it our printed elements. So not the printed elements, but our matrix in spiral order, that result. So the matrix in spiral order. That means we're going to be adding it to that result, and we're going to iterate it, and finally we'll return the matrix in spiral order. This will allow us to, if there's only 1 row, to not have to perform any of the other spiral matrix printing rather, because if there's 1 row, it's not a spiral order, it's just all the elements in order. Another edge case, very similar. Can you think what is another edge case? We have currently checked if the rows is 1, but what if the columns is 1? That would mean we have a matrix per se of 1 column. So that's another case we want to check for, because it's still not spiral order that we would have to perform on this. But still we would have to account for this kind of matrix because the input could be quite bizarre like that. So we'll check if the matrix at the 0th row dot size, which gives me the number of columns, if it's equal to 1, the number of columns. Then in that case, what I want to do is take the matrix and map to it the matrix in spiral order, and I want to iterate at the 0th row there. And then I want to, outside of the mapping but inside of the if statement, I want to return the matrix in spiral order, because in any of these cases we want to return out of the function. We don't want to perform the spiral order printing because there's no matrix really. It's just a 1-dimensional matrix in that case, not a 2-dimensional matrix. Now that we have all of the edge cases accounted for, let's go ahead and actually build out the functionality that's going to print it in spiral order. So first I'm going to need to go ahead and make a value called the middle x, and this is going to be equal to if the matrix dot size mod 2 is equal to 0. That means that we have an even number of rows, And if that is true, we want to take the matrix dot size minus 1 and divide it by 2. Now, otherwise, we want to add an else statement. So I'm going to add an else down here. I'm going to assign that to equal the matrix dot size divided by 2. And then outside of that, I'm going to do a similar task for the middle y. This will be if the matrix at the 0th column dot size, or the 0th row, if the number of columns is even, if the number of columns mod 2 is equal to 0. Well, in that case, we want to go ahead and open up that condition and assign the middle y, which is the midpoint of the matrix. That is going to be equal to the matrix at the 0th row dot size minus 1 divided by 2. And just make sure you wrap the subtraction always in parentheses, otherwise the calculation can become messed up due to order of operations, of course. Alright, so now that we have our midpoint, we can then go ahead and go through all of the rows and columns in a matrix. So what we'll do in this case is we're going to go ahead and initialize a variable called row. That'll be 0, as well as column equals 0. We need this in order to loop through the matrix. And we'll also make a variable called the depth, and this will be equal to 0. That is where we are in the matrix. So we'll make a while loop to go through while row is less than or equal to the middle x, and while the column is less than or equal to the middle y, the midpoints, and while the depth is less than or equal to the middle x, and while the depth is less than or equal to the middle y. So the depth must be less than the middle, and so must the current element that we are at. I'm just going to add a space here so you can see. There you go. Now you can see exactly what's going on there. And see what we're getting here. I'm kind of interested. Oh, that's fine. It'll be okay. Alright, so in this case, what we want to do is show that we're going deeper into the matrix. So we'll set the row to equal the depth and the column to also equal the depth, the index that we're at currently. After that, we're going to use a while loop in order to do the printing. So we will take while the column is less than the matrix at 0 dot size, the number of columns, minus the depth. The depth is used to go deeper into the matrix to chop off those. In here, we're going to check if the printed elements has not currently been printed at the current row and column. Well, that means we have to print it. So we have to take our, let's see, what did we call this? We have to take that result that we have, the result of the list, the matrix in spiral order. That is the result that we're returning. So we have to copy that, and we have to add to it the matrix at the current row and the current column. And then we'll take our matrix printed elements. We'll take the printed elements at the current row and the current column, and we'll assign it to equal to true. Why? Well, because we just printed it. So we don't want to print it twice. That is definitely something you want to watch out for with this question, is printing an element twice accidentally. Definitely we do not want that. And after this, we have to increase the column number each time, because otherwise we would get stuck with a nasty infinite loop, which we do not want. Infinite loops are definitely what you want to avoid. So outside of the loop, you want to also decrease the overall column and increase the overall row. Why? In order to go deeper into the matrix. So after this, we're going to continue with the pattern of spiral order, which is to go while the row is less than the matrix dot size minus depth. And what we'll do is check if the printed elements has not been printed right now so far, then in that case we are going to go ahead and print it. So we're kind of following the exact same functionality here to print it, so we'll just copy that over. It'll be faster. Bam. Just like that, we'll print it again, and this time what do we have to increment? The row, because we are looping through the rows. So we increment the row to avoid getting stuck in the infinite loop. Alright, and similarly we have to come down here, and this time we're going to decrease the row and increase the column because we have just looped through the rows. Now we're going to make another while loop, so quite a few loops here. And what we're going to loop this time is we're going to loop through while the column is greater than or equal to the depth. And what we'll do in this case is we'll perform the same check. If the current value has not been printed before, we'll print it. So I'm going to copy this if conditional and paste it in because it's the exact same, and you could even extract this if you'd like, but for the sake of simplicity and readability, I'm just going to leave it. Optimization can be handled for later. Typically on these tests, you just want to solve the question as quickly as possible using the patterns you've recognized, and optimization would come later if you have time. And because we just looped through the columns, what do we want to do? We want to decrease the columns. Those are the rules of the spiral order. We need to decrease the columns this time. And outside of the loop, we want to increase the column and decrease the row. There you go. And I'm just going to zoom out so you can see a bit better. That should be allowing you to see more of the overall functionality. There you go. Alright, and we still have to continue with the steps, spiral order. There are 4 steps. You go through the top, then down, then across, then up. And I'm going to go ahead and add in the last step there. I'm going to check while the row is greater than the depth. We want to perform the exact same check here. Oops, let's see. We'll just copy this. And if the current element has not been printed, please print it in spiral order, is what we're telling the compiler there. Then we have to decrease the row as per the rules of spiral order. And finally, outside of this while loop, at the very end of all of the loops, we have to increase the depth. This will allow us to go deeper into the matrix because otherwise we would just print the outside there. And finally, what we want to do is return the result. And our result is the matrix in spiral order. Alright, so that is all the functionality you need. You may be thinking there's quite a few steps. Well, that's because we have to go through 4 different steps as per the rules of spiral order. And we have to repeat that pattern over and over again throughout the depth of the matrix, deeper and deeper into it. So outside of the class, let's test this out. Let's open up a bad main function. By bad, I mean good. And it was going to be an array of type string as the arguments there. And of course you can use different data types or generics, but for the sake of simplicity we'll do this. The focus is the solution here. So I'm going to make a new value called spiral matrix, and this is going to be an initialization of the spiral matrix class to make an object. And then we can use that object's methods. And what we'll do is we'll make a value called the input array. And this will be an array of different values that we want to print. So this is where I'm building out our 2D matrix. I'll make one row by building an integer array of values like 1, 2, 3, followed by a comma to separate each row, and I'll add another row, 4, 5, 6. Of course, you can use any values you'd like. Array of 7, 8, 9. Okay. Excellent. So right now we have an object and an array. Let's call print line to print this to the console, and we'll print the spiral matrix object, and we'll call its spiral order function. Now, what did we call this? To print it in spiral order, print spiral matrix. There you go. Copy that name and paste it exactly after the object name, and put in the required arguments, which in this case is going to be just an input array. And let's go ahead and hit run, and we'll see the result in action. Let's see, if must have both main and else branches. Interesting. Let's see where this is. I'm going to just check this. Yes, okay. It could have not wanted. Yep. Okay, so the while loop did not like the space. Oh, well, actually looks okay. Let's check something else. Never mind. Okay. This if statement that we used, I'm just going to, don't need help. I'm just going to close the console. So it doesn't like that we're assigning the if statement like that. So all we have to do is just remove the curly brackets. I just did that for readability because otherwise you would have a harder time understanding the assignment there. But for the console, it wants us to put it all on the same line. And why? Because that way it can read what is the actual assignment. Let's see. Yeah, okay, that fixed it. You see, just like that. It just didn't like the curly brackets, but that is harder to read, so I will put it in because it forces me to. But at least you saw it in a clean format. Okay, excellent. Let's see. What is it telling me now? Let's see. Must have both if and else branches. Oh, I see. I just forgot to initialize the middle y. Not a problem. We can go ahead and initialize the rest of the middle y. We just need to add an else statement. Now, how could I forget that? We'll just add an else. Well, that's why the compiler is there. So we'll add an else statement. If we cannot put in the required value, we'll just put in the matrix.size divided by 2. Now that will only be if we don't have an even number of columns. So I'm just going to zoom out so you can see it and just make sure it matches this exactly. I'll just add a space. That way you can see exactly what we have here. There you go. Okay, so let's go ahead and hit run now and test this out. Oh, you know what it is? We have to decrease the column here, of course. Okay. We increased the column by accident. We just have to decrease it. There you go. All right, now we have our matrix being printed in spiral order. So spiral order 1, 2, 3, that is the top row. Then we have 6, 9, that is the last column. Then we have 8, 7, which is going across the last row backwards, and then we go up through the first row. 7, 4, and finally we go deeper into the matrix to print the last value 5, and we stop with no errors. Perfect. Now I encourage you to go ahead and test this on different matrices as well. Bigger matrices, different values, different data types. As you test it on different inputs, you will see, perhaps you'll discover some edge cases that we may have to also account for as a challenge. But other than that, we have gone ahead and solved this interview question of spiral matrix. Quite a common question, so congratulations everyone. Congratulations everyone on solving the spiral matrix interview question. Head on over to the next lecture where we're going to look at a more advanced question pertaining to matrices.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only do we get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.